Hi, we are Jolie and Gia, and we are from Harmony School of Innovation Sugarland. This is the Stop and Go reaction experiment.
Regarding the ELA component, we decided to use the journal entries. Doing so allowed us to document our process and look back at it if we need to. We wrote about each of the tasks and how they went. Some went well and some didn't. We discussed our successes and failures, the details and outcomes of the experiment, and much more. To check that out and see an in-depth look at the process, go to the page labeled ELA component.
As for the social studies component, we decided to explain historical connections. We explained the discovery of chemical reactions and reverse reactions. We also discussed how this knowledge greatly contributed to future scientific concepts. To learn more about the development of chemical reactions and reverse reactions, check out the page labeled Social Studies component.
In our experiment, we are going to talk about and demonstrate chemical reactions and reverse reactions. We will talk about the science of the experiment while we demonstrate, but visit the website page called Background Knowledge if you would like a better understanding of these terms.
We have all our materials placed here in front of us for this demonstration. So to start the experiment, make sure you have the materials listed in the materials section of our website and have read the safety section of our website to understand the hazards of our experiment.
Once you have read the safety section, gather the materials and place 50 milliliters of dextrose solution and 50 milliliters of sodium hydroxide solution in a 250 milliliter Erlenmeyer flask. There is a reaction going on here, but we just can't see it.
This is where the indigo carmine solution comes in. Indigo carmine is a dye that is used as an indicator so we can observe the color changes. We add 5 milliliters of indigo carmine solution to the flask and insert a stopper firmly. Make sure to let the solution sit still until it turns yellow. We do this to let the solution settle into its fully reduced state, which is in a yellow color.
Shake the flask and observe the color change from yellow to red to green and then back to yellow. The color change takes place because the solution needs oxygen to work. When shaking it slightly, the surrounding oxygen dissolves into the solution and reacts with the dye to make a red color. Shaking the flask strongly will make more of the oxygen dissolve into the solution, reacting with the dye more to make a green color.
What's interesting is that if the solution is left alone, the colors will transition back to get the original yellow color. This happens because the oxygen that originally made the solution turn from yellow to red to green is reduced in the solution while it sits still for a while. Reducing the oxygen will make the solution go from green to red to yellow.
If you're interested, this experiment is repeatable. You can use the same solution and keep shaking to repeat the color transition for at least 10 times. This experiment can also be accomplished using a different indicator like methylene blue dye. Also, a magnetic stir can be used to quicken the color changing process.
This experiment shows the concept of chemical reactions and reverse reactions mentioned earlier. The indicator that shows a chemical reaction has taken place is the color change. Thank you for watching our video and following our progress.
Thanks for watching our video from Harmony School of Innovation Sugarland.